Welcome to an introduction on trigonometric graphs, and what we'll quite often shorten this to is trig graphs. Now there are three main graphs which you will come across in this topic. First of all, there is something called a sine graph. Now sine we spell S-I-N-E, but when we're using it on our calculator, like you'll have experienced when you do the sine rule, we just type in S-I-N. Now, this is a function of x, and what that means is that if you plug in an x, you will get a y. So when x is 0, y is 0. When x is 90, y is 1. When x is 180, y is 0. When x is 270, y is minus 1. When x is 360, y is 0. And if I zoom out, what you will quickly see is that this wave goes on and on and on. It is an unending wave. You may also have seen things that look like this before, and if you've taken physics, you will have most likely come across sound waves, light, anything on the electromagnetic spectrum, you will see these waves. But we're going to think about light waves, not light waves, sound waves, for the majority of these videos, because that's something we can really imagine manipulating. So this is our sine wave. Now, the next one we come across, again, if you think back to your area of a triangle, your sine rule, you also had your cosine rule. Now that is cos x. You'll have seen it in SOHCAHTOA. Cos x looks pretty similar to sine x at first glance, but notice where sine x started at 0, 0, sine's now the green, cos starts at 0, 1. But apart from that, the graph is absolutely parallel the whole way along. And that's quite important because actually in sound, what they tend to do is have multiple sine waves and multiple cos waves, and they all merge together. So that image you see of a sound of somebody talking with lots of squiggles up and down, that's a combination of lots of sine and cosine waves. The last type of wave we are going to look at is the tangent, tan. So y equals tan of x. And in comparison to sine and cosine, tan is quite an intimidating wave. And the reason for that is as we zoom out, you will see it doesn't change. It essentially ends up looking like straight lines. Now, what does this mean when it comes to drawing it? Well, we start at 0, 0, and then we shoot off to infinity just before 90, but you never actually touch the line for 90. See how even now, up at the top there is still a gap. That is really important, is you never actually touch 90. But then at the bottom, we reappear, again, never quite touching never quite touching the line, even at the negative side. So we start at 0, we curve and then shoot off to infinity. We reappear at the bottom and we curve up to 180. We go through 180 and then we repeat what we've just done. Slow curve and then you shoot off, never quite touching 270, and then you reappear at the bottom and curve up towards 360. The fact we shoot off to infinity highlights another key difference. Your sine and your cosine, the standard sine and cosine, are trapped between 1 and minus 1. They repeat after 360 degrees, so that is what we call its period, and it is bound between -1 and 1, so it has an amplitude of 1. Again, looking back at tan, to reuse those words for amplitude and period, the period of tan, how long before it repeats? It repeats after 180, so tan has a period of 180, but its amplitude is undefined, it's infinite, because it will forever be higher than you can possibly imagine.